Hi. So very quickly, why should we worry about things like SIP over WebSockets on Kamailio? Well, one thing that it means that you can do is if you have an existing SIP system out there that you happen to want to make calls into, and there's a friendly one here, you can, from a web browser, make a phone call. WebRTC, it takes a few seconds gathering some ICE candidates. Can't wait for Trickle ICE to come along. But once that's done...
Simply the only person in this conference.
No, it's a true phone.
So that's
No, it's...
that's a friendly SIP server that just happens to be on the internet that we can peer with. No particular configuration needed, and that's why SIP over WebSockets can be very useful to you. So that's what I'm going to talk about here. So what are WebSockets? Well, WebSockets is just a way of communicating from the browser to a server. So it's safe and secure. You don't really want to give JavaScript programmers access to TCP and UDP raw sockets. Somebody puts something on a website, all of a sudden, a distributed denial of service attack would only require people to actually browse to a page and their computer would be taken over. WebSockets prevents that. And it does this because the protocol is asynchronous. There's a whole lot of masking and other bits and pieces going on. You can see that in the specification if you want to. It's RFC 6455 if you're really interested. And it can be secured using TLS. So it's a nice, secure way of getting data from a browser to a server and having bidirectional communication. So just a quick word of warning, anybody who wants to use WebSockets, proxies are often a problem, especially inline proxies. This happens a lot on mobile networks where they effectively intercept and interfere with the HTTP traffic between your client and your server. There's one in the UK that will strip out any header that starts upgrade : which means that your WebSocket handshake will fail. But you can just use TLS, which is good practice anyway. They can't access the headers, they can't change them, and even on those networks that want to try and block this kind of thing, it still works. If you're going to use a proper proxy in the way, then it needs to support the connect HTTP request. This has been in the HTTP 1.1 specification right from the beginning, but a lot of proxies never bothered implementing it. What that connect request does is it means that Chrome or Firefox or Internet Explorer or whatever will tell the proxy that actually it shouldn't close the connection after it's received a response to this first HTTP request. That's important with WebSockets because in order to have your bidirectional communication, you need to keep the connection open. One useful thing about WebSockets is that although it's just a transport, you can define subprotocols, which means that while establishing the handshake, the client can tell the server what protocol it wants to put on that connection. It's not like TCP or UDP, where you determine protocol really based on the port it arrives on. In the handshake, you effectively negotiate your subprotocol. And the subprotocols that are have standards for them are listed on the IANA website. So there's been lots of talk about WebRTC. There's been a whole bunch of sessions. This is what the WebRTC charter says about it. And but the WebRTC APIs on their own just aren't enough. Google made a very good decision right at the beginning, which is not to mandate signaling. And so that opens up the door to you being able to do what is right for your application. Signaling of some form is needed, because if you've got two browsers capable of real-time communication, you somehow have to tell one browser what the other's IP address it is, what codecs it supports, and negotiate all of this. Now, signaling can be proprietary, it can be standardized, you can use XMPP, you can use REST, you can use SIP. There's a wide variety of choices. What's right for you really is down to what your application is. And effectively, this is the famous signaling trapezoid. The media goes peer-to-peer, but you do need some sort of network resource to establish that connection in the first place. And so I'm going to talk about SIP over WebSockets because that's what is in Kamailio. I believe the open standards are usually the best. Now, that means XMPP and SIP. I don't like proprietary standards. And SIP over WebSockets is currently going through the IETF now. The big advantage that SIP over WebSockets has is there are a huge number of implementations out there. So you've got a great deal of choice if you're setting up your own system. There's Asterisk, there's Kamailio, there's OverSIP, there's vSiprocate, and there are probably more. There's even a huge number of client implementations. I'm not sure, but I don't think there are any other sort of WebRTC-related signaling protocols that are standards-based that has such a wide variety of implementation choices. And how it works on Kamailio is that WebSockets is just another transport. You've got TCP, TLS, and UDP already on Kamailio. WebSocket is now there as a transport. And so if you want to use WebSocket on Kamailio, there's a few basic modules that you need. You need the XHTTP module because you handle an HTTP GET request as the WebSocket handshake. You need the SL module because that's required by the XHTTP module. You need the WebSocket module because that has implemented the WebSocket framing and decoding. And because of the way WebSocket works, which I'll go into in a minute, you need some mechanism of doing SIP-NAT traversal. And there are two modules on Kamailio for that. In fact, there are several, but there are two that work particularly well here, NAT helper and outbound. And depending on what else you're wanting to do, there are a couple of other useful modules, auth ephemeral and RTP-proxy-ng, and I'll talk about them a bit later. So to handle this WebSocket handshake, a WebSocket handshake is effectively an HTTP GET with some special headers in it. So on Kamailio, when you're using the XHTTP module, you have this event route XHTTP request, and you can define how that HTTP request is handled. And you do some cursory checks to make sure this really does look like it's a WebSocket handshake. You can do some additional validation, so before even accepting the handshake based on headers that will be in there. And then it's as simple as calling WS handle handshake. That will do further checks on the message. It will make sure that everything's okay, and if it is, then it will establish the WebSocket connection, and any future messages that come into here will be processed and dropped into the main Kamailio processing. Now, WebSocket clients are effectively always behind a NAT. And this is because JavaScript applications can't see the real IP address and port that the WebSocket connection in the browser is using. So this means that the SIP server cannot trust any addresses that might be embedded in the SIP message, because the JavaScript will embed these addresses in the SIP message, and they can't be trusted. This is exactly the same problem you have if you've got a SIP client that's behind a NAT firewall, because, of course, the PC behind the NAT firewall doesn't know what the outside address of that NAT is. And Kamailio already has solutions for this. And the simplest if you're on a single server is to use the NAT helper module. And here, in your initial request route, after you've done your initial checks, you do a WebSocket detect, which checks to see if it's coming over WebSockets or secure WebSockets. And if it has, it does this stuff here, which is all that you need to do in order to embed real information in the SIP message that will allow routing back to the client. And what will happen is, within a dialog, when you send a buy or have another SIP message going along, this information is now embedded in the message flow, and you just use this handle our URI alias to reinstate it. You can find all this documented in that helper module documentation. It's all the absolute standard stuff that you would need to do setting up any Kamailio server. And the point I'm trying to make here is that with WebSockets, it pretty much just works. And in your reply route, of course, you need to embed some extra information in there as well. So the great thing about WebRTC is my two browsers can now talk to each other. But what happens if I now want to talk from my browser to a non-WebRTC endpoint? The RTP profile for WebRTC and the RTP profile that's out there in wide use today are quite different. But there's a great new bit of software called mediaproxy-ng written by the guys at SIPwise. They're based in Vienna in Austria, called mediaproxy-ng. And rather confusingly, there's a companion Kamailio module for controlling this called RTP-proxy-ng. Now, Klaus mentioned that Kamailio can control media proxies. And the big advantage to doing something like this is that you don't have to back-to-back your signaling. You don't have to put any clever hacks into your media server to preserve transparency of signaling. It just works. So this is the example I have been running out on the booth, and you can come and see it if you want. But I have here a SIP over WebSocket client, which is being served off of Raspberry Pi. I have Kamailio and mediaproxy-ng running on the Raspberry Pi. And I can just make a phone call, and this rings. And this is a traditional SIP phone that doesn't do any of the security, doesn't do any of the feedback or the bundling or anything else that you need for WebRTC, but you can interwork the two. And that can be used on your SIP trunks out to ITSPs and other things as well. And how you invoke something like this? Well, you just configure RTP proxy-ng to where it should send the control signals to. When you send your traffic to another user agent, you arm this failure route so that if an error comes back from the user agent, this route will be run. In this route, you check for a 488, and 488 means that it didn't understand the media description that was in the invite. At which point, you extract some information from the media invite, and you determine whether or not this was from a WebRTC or a non-WebRTC endpoint. You then set up some flags, which will control how mediaproxy-ng works, and then you append a branch to do a serial fork so that you can send the invite on again. You arm the RTP proxy. You tell it to get ready to proxy the media. And you also arm this route so that when a reply comes back from the media proxy, and then you send the call out again. And then when your reply comes back to the invite, effectively, you call mediaproxy-ng again. And what ends up happening here is that where with WebRTC media would normally go directly between the endpoints, it now gets forced through the media proxy, and the media proxy decrypts in one direction and encrypts in another. Yeah, because if you've got a system where you may have WebRTC and non-WebRTC endpoints, if you've got two non-WebRTC endpoints talking to each other, you don't want to go through the mediaproxy-ng. And if you've got two WebRTC endpoints talking to each other, you don't want to go through mediaproxy-ng. You only want to go through there when you actually have to. Now, there are a couple of limitations in the current mediaproxy-ng. First of all, there's no support for SRTP DTLS, which is a must-have for WebRTC. The current mechanism, SRTP-SDES, is a must-not. However, it still works with Google Chrome today, and I believe that although this will be removed within a year, that's plenty of time, and I think mediaproxy-ng will support this by then. It does, however, mean that it won't work with Firefox quite yet. And it doesn't support bundling and unbundling, which means that WebRTC can bundle audio and video streams together, but mediaproxy-ng doesn't support unbundling them to go to endpoints that don't support that yet. I believe Chrome is supposed to support unbundling the right situations, but it doesn't quite do that properly either, and those two limitations tend to mean that you can have an audio stream through mediaproxy-ng or you can have a video stream through a mediaproxy-ng, but you can't have both today. So one of the big things you can do here now is, of course, you can load balance traffic to Asterisk. Asterisk has SIP over WebSocket support. That's a great thing. But perhaps you want to put more through there than you can have to one Asterisk server. And the way you do that is you use a load balancing module. And Kamailio has many of them, but the simplest and easiest to use is Dispatcher. And Dispatcher load balances traffic across a set of SIP destinations, and it has a whole great long list of algorithms. Somebody was asking about how do you make sure traffic goes to the same system. Well, that would be the hash over RURI here, one here. Dispatcher can also keep track of destinations. It can probe them to make sure they're still up. So you can take an Asterisk server out of service. Dispatcher will notice this and automatically remove it from the set of destinations it's going to use. And the simplest way to use load balancing is, for example, to distribute traffic across something. Now, you don't care about failover, and it really is as simple as configuring the dispatcher module to pick some stuff out of a database or a file, and then saying select a destination from set number 0 using algorithm 4, which is round robin. If that fails, say so, but other than that, relay it. And as simple as that, that is all that you need if you want to load balance some traffic. If you want to put failover support in dispatcher, there's a whole bunch of extra module parameters that need to be set up, and they need to use failure routes and all sorts of other things. There are a huge number of examples available, including, I believe, in the presentation Klaus mentioned from previous Astricon, and the documentation is excellent for this module, and it's available there. And just as a quick example here, once you've actually got it all set up, you can use the camctl bit of software to actually provision your load-balanced destinations and tell you what's in there. So you don't even have to interact with the database directly if you don't want to. The Kamailio camctl program will do that for you. And the final thing I really want to talk about today is integration of Kamailio with the web, which is kind of important for WebRTC. SIP traditionally uses MD5 digest authentication, and you would traditionally have to provision user accounts onto the SIP server. That isn't the best way when you're on the web. That's not really what you want to do at all. You don't want to have to provision an account onto your SIP server. You just kind of want the SIP server to work. You want it to be unified into whatever authentication you already have for your website. You want to have identity federation so people can sign in with OpenID, or so that they can sign in with Facebook or Twitter or whatever. And there's a new Kamailio module that does this. Now, Google came up with a model for turn server authentication and access, where you communicate with a RESTful web service, you authenticate against it, and it will return back a time-limited credential and also tell you what server to talk to. And this is applicable to a wide variety of protocols, more than over and above just turn. So Auth Ephemeral in Kamailio does this for you. There's no communication required between the authentication server and Kamailio. You just configure a shared secret on the web service and on Kamailio. What you would do is you would go to the web service and say, you would authenticate with it and say, give me a credential. And the web service will give you a credential that consists of a timestamp, colon, and a username. It will have a password that comes back with that credential, which is a base64 encoded hash of the encryption of that username encrypted with the shared secret. You can then pass that into Kamailio, and Kamailio can re-encrypt that username and compare it. And it can also check the timestamp. So if the timestamp is in the past, the credential is expired, it rejects you. If the credential doesn't pass the encryption test, that's rejected as well. As well as that, Auth Ephemeral has some additional APIs so that you can recheck the timestamp at later times, and you can check the from URI and the to URI in the SIP messaging against the user part of that credential, which means that people can't even spoof their username and identity in the SIP. And so an example of how you might do that, there's a much more complicated HTTP event route for the WebSocket handshake here. And what this is saying is it's expecting a URI now for the WebSocket connection that actually has some parameters on it, username equals and password equals. And this little bit here, it does transformations. Klaus talked about those. The first one extracts the query string, which is the part after the question mark from the URI. And the second one extracts the parameter named username and the parameter named password. It then applies ephemeral authentication to the username and password, and if they don't match, or if the timestamp's expired, it rejects the WebSocket handshake. It then continues on to do the WebSocket handshake, and if that succeeds, it stores the WebSocket, the username that was retrieved from here in a hash table. And finally, when the WebSocket's closed, it will remove the information for that connection from the hash table. And now, when your SIP request comes in, inside the WS detect route, you retrieve the username from the hash table. If it's not in there, You reject the SIP message and you close the WebSocket port. Somebody's trying to hack you. You then recheck the timestamp because this WebSocket connection could have been authenticated 2 hours ago and the credential may have expired. If it's expired, you reject it and close the connection. Then if it's a register or a publish, you check that the username, the actual user part of this credential matches the to header. If it doesn't, somebody's trying to hack you and you reject it. And if it's an out-of-dialog request, which means it's a message or an invite or something else, but it's not a register or a publish, you check that it matches the from header. And again, if it doesn't, somebody's trying to hack you. And so by doing this, you can do you don't have to challenge every SIP message. You can authenticate at the WebSocket connection time. You can cache that information. You can make sure people are not using this WebSocket connection any longer than they should be. And you can verify that the identity information that's included within these SIP requests matches how that person authenticated with the WebSocket and connection. And none of this requires any credentials or user accounts to be created on Kamailio, which means that if your web service integrates with Facebook or Twitter or OpenID or anything else, all of a sudden you have identity federation for your real-time communications in SIP. The configuration files, this presentation and everything I'll put up on GitHub. And if anybody needs to talk to me, that's where it is there. I'm sorry it's been very, very highly technical and I've talked very quickly because there was a lot to go through, but I'll be around as well. So if there are detailed questions anybody has, come and find me. I'll be on the Kamailio stand all tomorrow. No? Well, that's the point. There doesn't have to be. Your web service generates the ephemeral credential that is used with the auth ephemeral module. You will authenticate with your web service in some way or another. Many websites authenticate, people log in using their Facebook accounts. If you have such a website where you log in using that Facebook account, that website, as you log in, can set some cookies or can provide a JSON object back after you've logged in with an ephemeral credential in it. The point is that Kamailio doesn't need user accounts. It doesn't need to be integrated or connected to any other system. As long as that web service provides information to your JavaScript application, you can log in.
More questions? Can you talk a little bit about, you said that that's running on a Raspberry Pi?
Well, right now what's running on the Raspberry Pi is we've got mediaproxy-ng and Kamailio, which means that this Raspberry Pi, for example, you could use that as an Office PBX. You could serve a JavaScript client instead of people installing a soft phone. You could configure a trunk from this Raspberry Pi out to your ITSP, and if you so wanted, you could have a small Office PBX. And Tim Panton, probably with a difficult question up the back there.
Just curious to know whether mediaproxy-ng does transcoding as well?
It doesn't do any transcoding, so the reason it all works is that PCMU or PCMA G711 is in there. It does do repacketization, so if you decided that you really wanted 10 millisecond packets instead of 30 millisecond packets, it'll do that for you, but it won't actually do any transcoding. mediaproxy-ng can bridge between IPv4 and IPv6, but it can't bridge between two IPv4 networks and two IPv6 networks. So you've got a choice. You can use RTP proxy if you don't need WebRTC and you need to bridge, or you can use RTP proxy or mediaproxy-ng if you want to use WebRTC. If you want to use WebRTC, you'd better not want bridging because it doesn't really work at the moment. It's open source. I'm quite sure the SIPWise guys would be happy for somebody to contribute that if they wanted. Yeah, but the point is it's an open source project. The reason the SIPWise people haven't added it is they don't need it yet. But if somebody wanted it, I'm sure they'd be welcome to add it.
Was there anything special that you put on the configurations or the modules? Any modifications that had to be made, or is that just the?
No, this is absolutely standard Kamailio from the master branch of Git as of Sunday morning. And it's absolutely standard mediaproxy-ng from the master branch of that Git, again, from Sunday morning and just built.